When dealing with electric fences near high-voltage power lines, especially those operating under 345,000 volts, understanding the safe and effective switching of high-voltage, low-current circuits is crucial. The primary concern is how to safely ground the fence when it's not in use, especially given the presence of induced voltage from the overhead power lines. Traditional knife switches may not be suitable or safe for this application, leading to the need for specialized high-voltage, low-current switches. Several types of switches are appropriate for this scenario. Firstly, high-voltage relays, specifically solid-state relays, offer a solution for switching high voltages with very low currents. These relays are available in ratings up to 1000 volts and 100 milliamps, making them suitable for applications where precise control and safety are paramount. Secondly, soft-start relays are designed to gradually apply voltage to a circuit, which reduces the inrush current. They can be effectively used to switch high-voltage loads with milliamp currents, providing a smoother and safer operation compared to traditional switches. Thirdly, vacuum contactors use vacuum-sealed contacts to switch high voltages. They have low contact resistance and can handle milliamp currents efficiently. These contactors are known for their reliability and longevity in high-voltage applications. For specific recommendations, consider the following. A high-voltage solid-state relay, such as the Omon G3VM240D, is rated for 1000 volts and 25 milliamps. This relay is a good choice for its compact size and solid-state reliability. A soft-start relay, such as the Franklin Electric 760, is rated for 1000 volts and 30 milliamps. This option provides the added benefit of reducing inrush current, which can prolong the life of the fence components. A vacuum contactor, such as the Schneider Electric TSYS GV3, is rated for 1000 volts and 15 milliamps. Vacuum contactors are known for their durability and suitability for high-voltage switching. To safely ground the fence with a switch, follow these steps. 1. Install a heavy-duty switch rated for the high voltage and low current requirements of the fence. This ensures the switch can handle the induced voltage without failing. 2. Connect one terminal of the switch to the fence. This connection should be secure and properly insulated to prevent accidental contact. 3. Connect the other terminal of the switch to a grounding electrode, such as a copper rod driven into the ground. The grounding electrode should be properly installed to provide a low resistance path to ground. 4. When the switch is closed, the fence will be grounded, discharging any induced voltage to the earth. 5. When the switch is open, the fence will be ungrounded and energized by the overhead power lines, allowing it to function as intended. It is important to note that high-voltage electrical work should only be performed by qualified and licensed electricians. Strict safety precautions must be taken to avoid electric shock and injury. This includes wearing appropriate personal protective equipment, such as insulated gloves and safety glasses, and ensuring that all power sources are energized before working on the electrical system. Consider the following aspects when selecting and installing a high-voltage, low-current switch for an electric fence. First, voltage rating. The switch must have a voltage rating that exceeds the maximum induced voltage on the fence. In this case, since the fence has been measured with 400 volts to 800 volts when it is off, a switch rated for 1000 volts or higher is recommended to provide a safety margin. Second, current rating. While the current is low, the switch must be able to handle the expected milliamp current without overheating or failing. Check the specifications of the switch to ensure it meets the current requirements of the application. Third, insulation. The switch should have adequate insulation to prevent arcing or short circuits. Look for switches with high dielectric strength and robust insulation materials. Fourth, environmental protection. If the switch is installed outdoors, it should be protected from the elements. Choose a switch with a weatherproof enclosure to prevent moisture, dust, and other contaminants from affecting its performance. Fifth, safety features. Look for switches with built-in safety features, such as lockout/tagout mechanisms to prevent accidental operation during maintenance or repair. Sixth, compliance. Ensure the switch complies with relevant safety standards and regulations, such as those set by the National Electrical Code or other applicable codes. Consider the potential for transient voltages and surges on the fence. These can occur due to lightning strikes or other electrical disturbances. To protect the switch and other electrical components, consider installing surge protection devices on the fence. These devices can help to dissipate transient voltages and prevent damage to the equipment. Also, regular inspection and maintenance of the switch and grounding system are essential to ensure continued safe and reliable operation. Check the switch for signs of wear, corrosion, or damage and replace it if necessary. Inspect the grounding electrode to ensure it is still properly connected and providing a low resistance path to ground. Testing the grounding system periodically is also recommended to verify its effectiveness. Use a ground resistance tester to measure the resistance between the grounding electrode and earth. A low resistance value indicates a good ground connection. In addition to the switch and grounding system, the overall design and installation of the electric fence should also be carefully considered to minimize the risk of electrical hazard. Ensure the fence is properly installed and maintained, with adequate spacing between the fence wires and other objects. Keep vegetation clear from the fence to prevent it from grounding out or causing shorts. Post warning signs around the fence to alert people to the presence of high voltage. These signs should be clearly visible and legible, and should comply with relevant safety regulations. If the electric fence is located near a public area, consider installing a physical barrier such as a fence or wall to prevent accidental contact with the energized fence wires. Also, consider the potential impact of the electric fence on wildlife. If the fence is located in an area where wildlife is present, take steps to minimize the risk of entanglement or injury to animals. This may involve adjusting the height and spacing of the fence wires or installing wildlife-friendly fencing materials. When working with high-voltage electrical systems, it is essential to follow all applicable safety procedures and regulations. This includes wearing appropriate personal protective equipment, using insulated tools, and verifying that all power sources are de-energized before working on the equipment. If you are not qualified to work on high-voltage electrical systems, do not attempt to do so. Hire a qualified and licensed electrician to perform the work. It is important to remember that electricity can be dangerous, and high-voltage electricity can be lethal. By following safe practices and taking appropriate precautions, you can minimize the risk of electrical shock and injury. Furthermore, consider the environmental conditions in which the switch will be operating. Temperature fluctuations, humidity, and exposure to corrosive substances can all affect the performance and lifespan of the switch. Choose a switch that is designed to withstand the specific environmental conditions in your area. For example, if the switch will be exposed to extreme temperatures, choose a switch with a wide operating temperature range. If the switch will be exposed to corrosive substances, choose a switch with corrosion-resistant materials. Another factor to consider is the switching speed of the switch. Some applications require fast switching speeds, while others do not. Choose a switch that has a switching speed that is appropriate for your application. For example, if you need to quickly de-energize the fence in an emergency, choose a switch with a fast switching speed. In addition to the technical aspects of selecting and installing a high-voltage, low-current switch, it is also important to consider the legal and regulatory requirements that apply to electric fences. These requirements can vary depending on your location, so it is important to check with your local authorities to ensure that you are in compliance. Some common legal and regulatory requirements for electric fences include permits. In some jurisdictions, you may need to obtain a permit before installing an electric fence. Setbacks. There may be setback requirements that specify how far the electric fence must be from property lines, roads, and other features. Signage. You may be required to post warning signs around the electric fence to alert people to the presence of high voltage. Inspections. Your electric fence may be subject to inspections by local authorities to ensure that it is in compliance with safety regulations. By understanding and complying with the legal and regulatory requirements that apply to electric fences, you can avoid potential fines, penalties, and other legal problems. When selecting a grounding electrode for the switch, consider the following factors. Material. Copper is a common material for grounding electrodes because it is a good conductor of electricity and is resistant to corrosion. Size. The size of the grounding electrode should be appropriate for the voltage and current levels of the electric fence. A larger grounding electrode will provide a lower resistance path to ground. Depth. The grounding electrode should be driven deep enough into the ground to reach a stable soil layer. The depth will vary depending on the soil conditions in your area. Location. The grounding electrode should be located in an area where it will be in contact with moist soil. This will help to ensure a low resistance path to ground. In addition to the grounding electrode, the grounding conductor should also be properly sized and installed. The grounding conductor is the wire that connects the switch to the grounding electrode. The size of the grounding conductor should be appropriate for the voltage and current levels of the electric fence. The grounding conductor should be installed in a way that minimizes the risk of damage or corrosion. Some additional safety tips for working with electric fences include: never work on an electric fence while it is energized. Always disconnect the power supply before performing any maintenance or repairs. Use insulated tools and equipment when working on an electric fence. Wear appropriate personal protective equipment such as insulated gloves and safety glasses. Never touch an electric fence with bare hands. Keep children and pets away from electric fences. Inspect the electric fence regularly for any signs of damage or wear. Repair any damage immediately. If you are not qualified to work on electric fences, hire a qualified and licensed electrician to perform the work. By following these safety tips, you can minimize the risk of electrical shock and injury when working with electric fences. Regularly inspect the fence for any signs of damage, such as broken wires, loose connections, or damaged insulators. Repair any damage immediately to prevent electrical hazards. Also, inspect the area around the fence for any vegetation that may be touching the fence wires. Trim any vegetation that is touching the fence wires to prevent it from grounding out the fence. Consider installing a lightning arrestor on the electric fence to protect it from lightning strikes. A lightning arrestor will help to divert the lightning energy to ground, preventing damage to the fence and other electrical equipment. Consult with a qualified electrician to determine the appropriate type and size of lightning arrestor for your electric fence. Educate people who may come into contact with the electric fence about the potential hazards and how to avoid them. Post warning signs around the fence to alert people to the presence of high voltage. Teach children and adults to never touch the fence wires. If someone does come into contact with the fence and receives an electric shock, provide first aid immediately and call for medical assistance. Familiarize yourself with the symptoms of electric shock and how to treat them. By taking these precautions, you can help to prevent accidents and injuries associated with electric fences. Remember, safety should always be the top priority when working with electricity. Ensure proper labeling and signage are in place to warn individuals about the presence of high voltage. This is especially important in areas where the public may have access to the fence. Regularly check the functionality of the warning signs and replace any that are damaged or missing. Furthermore, consider implementing a regular maintenance schedule for the electric fence to ensure that all components are functioning correctly and that the fence is operating safely. This may involve visual inspections, electrical testing, and component replacements as needed. Keep a log of all maintenance activities to track the performance of the fence over time and identify any potential issues before they become major problems. Stay informed about any changes to regulations or best practices related to electric fences and ensure that your fence complies with all applicable requirements. This may involve attending training courses, reading industry publications, or consulting with experts in the field. By staying up to date on the latest information, you can ensure that your electric fence is operating safely and effectively.